Hey, 1 2 1 2 1 2. Hey, good morning, good evening, and of course, good afternoon. 1 2 3 4. Hey, 1 2 3 4. 1 2, checking lavalier microphone. 1 2 3 4. 1 2 3 4. Check 1 2. Check 1 2.
I'm Cindy.
Something to tell that it's so well together. No, I mean, I don't want to stay forever. I basically want, cut off some, smell, sort of as quick as I can with some like a big well, like say, I don't know. What you're describing is
Yes? Okay.
Busy man. So we're gonna split after this starts going. Dave's gonna plan on coming back at noon to just check in and give everything a once over to make sure if there's any issues. We're gonna keep an eye on things. There's only so much we can do. If you have a problem, reboot, go to youtube.com, you know where to go, like that. And everything should come up exactly the same way. You may have to kick off the afternoon session to make it sync up. And it says afternoon session, Google Hangout on air, you click broadcast. That's all it should be. But text me, call me, hip chat me, smoke signal, whatever. And we'll see what we can do, because I can also play around with the controls on my end over there, but I need somebody in front of it to kind of just reboot that.
Real quick. We're going to get started in about 5 minutes with lightning talks. So I just want to give everybody a heads up if you want to finish up your breakfast and get settled. Just a request, if you guys could all wear your conference name badges. If you forgot it at the hotel, please go see the registration desk in the back. We can make you a new one. And any other questions that you have about the rest of today, find me, find DB. We'll get going with the lightning talks in about 5 minutes. Thank you.
All right, everyone. Oops. All right, everyone. Good morning. I'm DB. I'm going to be running the lightning talks this morning. The way the lightning talks work is very simple. Oh, louder? Can you hear me now? Is that any better? Awesome. Okay. So I'm DB. I'm going to be running the lightning talks this morning. The way the lightning talks work are very simple. Each person has a very short amount of time to give a presentation that is short, focused, and to the point. In the 9 a.m. to 10 a.m. slot, we're going to have 10-minute lightning talks. And then we're going to have the keynote from Gerald Sussman. And then from 11 to noon, we're going to have even shorter lightning talks, 5 minutes apiece. Because these lightning talks are so quick, there's no time for audience questions in between. So if you have questions that you'd like to ask each presenter, please remember who they are and go and talk to them one-on-one later on. So first up, we have Xavier Antiviat giving a presentation about jQuery Xblock. And on deck for the next presentation, we have Samuel Soberin talking about permanent expectations.
Okay, so I'm going to talk about jQuery Xblock. So you already know, especially if you've seen the presentation yesterday, that you can load Xblocks within edX. So this is a bit small, so you're going to see it, but there is one that I shown yesterday, which we see here in the courseware of the LMS, which is simple variation on the drag and drop thing. So you can drop something into an image, it sticks if it's at the right place, and it doesn't if it's at the wrong place. So this is like the general principle of Xblocks, having little parts of the interface, which can be an interactive exercise, anything going from displaying a PDF to MCQs to exercise like these videos, etc. All the content inside of courses in edX is or will be soon Xblocks. So this is all well when you're doing a course on edX, but sometimes you would want to display those exercises, those Xblocks, outside of the coursework content. This happened with one of the integration that we had to do. They wanted to display it within their own interface at a different place. You could imagine maybe putting it on your blog post or etc. So how do we do that? That's where jQuery Xblock comes into play. So it's a small jQuery plugin, which with a little bit of work of integration, allows to load remotely an Xblock. So you can see here that on a specific DOM element, we would load the XBlock plugin using course ID. So that's the course in which we were before, the precise location of that XBlock inside of the course content, the session ID, I'll come back to that later, this is for authentication, and where to get it on the sandbox from. So that's where the demo becomes a little bit tricky, and I hope it will work. We are going to try to do that within that presentation, try to load that XBlock from before. So let's try to put there, and copy and paste. Into the console. And I hope it will work. Here we go. We have the exercise that we had before, the drag and drop, that we can still use exactly the same as it was in the LMS. So just to finish with that, there are a couple of limitations currently to jQuery XBlock due to the way we had to integrate it this time. But hopefully, if there are more demands or other people interested in the audience into this concept, we can maybe extend it further. So authentication is one issue currently. It's not handled by jQuery XBlock, so you have to get the authentication token yourself. And it has to be on the same domain. But there is a minimal amount of work that could allow it to load remotely from anywhere and allow to do the authentication and maybe even anonymous sessions from the remote loading. So I encourage you to give it a try if you're interested. So there is the repo, jQuery XBlock, this was part of the work done in the edX solution teams. And there is a pull request to get it supported by the LMS. Currently, you need to pull the patch yourself. And if you need anything and have any problems with it, just send me an email or write me here in the conference, and I'll be happy to answer your questions. Thank you very much.
Hello, I am Samuel from Neodemia. We are a French company doing MOOCs for corporation. So I will talk about social interaction and gamification in MOOCs. That's the topic we are working on at Neodemia. So what is learning? I won't go into the details of the definition of learning, but social learning, as advocated by Andrea in the 1960s, states that learning is not purely behavioral, but rather a process that takes place in a social context. So it is especially visible in MOOCs where the most successful MOOCs are those where a lot of interaction occurred between participants. And at Neodemia, our first MOOC on creative writing had tremendous success because people could talk to each other and share their story and ask for advice. They could also build the course content and add their own resources thanks to collaborative tools. Social interaction today have never been so easy thanks to modern technologies such as high-speed internet, affordable computer, and webcam. We can gather thousands of people, make them interact seamlessly anywhere, anytime, and yet MOOC platform we believe MOOC platform lacks the proper tools to make this interaction happen. There are forums, there are even chats, but we think that these tools are outdated in the world of Facebook or Stack Overflow. So the goal is to empower MOOC participants, and so this is key to user implication and motivation, which in turn lead to better completion rate. So completion rates and MOOC platform. Completion rates is one of the most basic but also most interesting metrics for a MOOC platform because allow easy communication with stakeholder or media. So every MOOC platform wants to improve on that, and there are a lot of ways to improve this metric. Better teacher, by example, but this is not in the power of the platform provider. Good UX, and edX is already pretty good at that. But we believe that one of the most powerful leverage is community engagement. So what tool do we need to create community engagement? So at Neodemia, we are working on this question. We are working because we are a MOOC platform provider, and we are working also in a research project at the national and European level. So specifically, we are working on designing tools that allow the creation of a community and to empower our users to create this kind of community. A community where they have a role and are not anymore a silent anonymous. So how do we get there? We can learn from what others have done. We can look, by example, at Stack Overflow. We will build a community based on the transmission of knowledge. And in the 1920s, Célestin Freinet, a French teacher, theorized a pedagogy based on social interaction. And we can learn two things from this experiment. There is a need for a social network and also a need for a tool which allows peer recognition. So we believe there is the need for a social network which helps build confidence and allow people that don't express themselves easily publicly to express themselves to a more private audience. And it allows better control of the interaction and community feelings. And it allows the creation of small communities inside big cohorts. Gamification. So gamification, it goes with the creation of a kind of hierarchy among MOOCs participants. We can see that in effect in the judo with the belt. In judo's practitioners are ranking according to knowledge and skills, and those their level, their rank is indicated by the color of the belt they wear. These belts make very clear to which are the people who can help you and which are those that you can help. It creates rights and duty among the participants. And so, besides creating a strong community feeling, it allows an efficient management of classes. In martial arts, it is common that black belt take in charge the courses where the teacher has another obligation. So this kind of feature is highly desirable in MOOCs, where by definition the teacher can be unable to answer to every solicitation of the participants. And as a matter of fact, peer grading has been developed for the same kind of reasons. So, what we have done so far. So, we are in the process of creating these tools. We already have integrated Mozilla Open Badges inside edX platform by using a fork of Django Badger. So now we can create badges and award them to our participants. These badges play the role of the judo's belt. And so the next step is to make them very visible inside the platform, but also outside of the platform, thanks to the technology of Mozilla Open Badges, which allow the hosting of these badges outside of our platform. So maybe in the future, these badges will be shown on other sites like LinkedIn, Facebook, Yahoo. So in the meantime, we are developing a wall patch for users where they can see their news feed. It is not something revolutionary. And so that they could see what their friends are doing, they could speak to their friend more easily. And so with this solution, we think it will be possible to create more elaborated tools, allowing an effective gamification of every interaction occurring on the platform. So what's the perspective? So we want to go in the way that people could self-organize themselves in MOOCs, create groups, and allow an effective system of tutoring where more advanced students can help beginners. So a decentralized management of MOOCs, and so make participants actors of their learning experience. So thank you for your time. If you have more questions, I'll be available at the end. And I wanted to thank you, the edX community, for its engagement and for the great tools that have bring us. Thank you.
Next up, we have Carlos Tudo talking about UPV Xbox, to be followed by Ben Weeks talking about LaTeX to edX.
Hi, thanks. I'm Carlos Churro from UP Valencia in Spain. And just to give a quick overview of some things we are doing in 6 blocks. We are running edX as a platform for doing MOOCs. We have already 20 of that or so on. And one thing we like a lot about the platform is the ability to extend easily. So we are doing that for 6 blocks. If you have been looking at the talk of Xavier or the talk that Xavier did yesterday, then you can have a look of what Xbox mean. Anyway, just let's say that is a quite easy way to extend. So we like a lot because it allows us to give freedom to our teachers to make different things, the things that are in the core of the project. The best reference to know that is also from Xavier. So if you can get the report from yesterday or the small talk that has been telling, was have a look. Why? So the first reason for doing that is to avoid people to write HTML code. Nobody likes to write HTML code, it's prone to errors, it's prone to problems. So it's much easier to give a small box for writing and being able to do work, for instance, to display a PDF page. So this is about 40 lines of code. It's quite easy, it's doable by any programmer, and in the defense you have quite a long difference from the experience on your teacher or the experience from people that is working. So this is our first key block, is that the PDF viewer. And moving on, this has encouraged us to make more things. Let's say that while the Xbox world is broad, is deep, you can get deep and more deep involved. It's like there are like different levels, and you can stop whatever you want. So for instance, if you just want to avoid writing HTML code, it's quite easy to develop anything. If you want to store content and manage user input, you have to work a bit more, and in the highest level you can interact with other blogs, modify the behavior of the platform, and so on. So in this level we have made 4 X blocks. One is the PDF viewer, I showed you. Another one is the multi-tab viewer. It's for providing students with alternate views of the same thing. It's just the folders. We have integrated virtual labs. We have a lot of virtual labs done with Mathematica. We wanted to have it on the platform, and it's looking very nice. It's another Xbox. And also, we are working with an advanced video player, a dual video player we have, the Stepfire player that is integrated also. This is the PDF viewer I showed you before. The multi-tab viewer, so we have several tabs, and you can choose to display different things on the tabs. We use that usually we have used that, for instance, for displaying the video from different sources. Depending on we have some courses in China, so users in China usually wanted to look from Weibo or from YouTube, sorry, or iPhone website because YouTube is located in China. But you can also have in YouTube, but you can also have from our internal platform. So you have several different tabs, and you can choose between them. This is the Mathematica viewer. Has been a great success for us because we have a lot of teachers that are able to do a lot of things with Mathematica. So they wanted to use that instead of the MOOCs. So we just write an X blog. Teachers select the CDF file from Mathematica, and you have all. So then it's pretty easy for one that is using Mathematica to decide. Finally, as I was saying, we are running in a different project. We are doing a lot of lecture recording, and we have a player inside of the OpenCast Metaphor project that is called the Player Player. That is a dual view player. You have the slides, you have the teacher, you have a timeline of the slides, comments, and so on. And we have it integrated onto the MOOCs. So what? So that the teachers are able to put part of their current lectures into a MOOC. So any teacher that is doing a MOOC can say, oh, my talk that I gave last week is a very good example of what I want to know. I don't want to re-record it. So you select the beginning and the end time, you put inside, and you have the player with the video inside of the platform. So doing Xblocks is easy, it's fun, it's a great way to advance in the platform. We have the content shareable for anybody. So if you want to get that, you can get that. There's a list of Xblocks on the wiki for OpenEDX. And that's all. If you have any questions, I'll be around. Thanks.
Next up, we have Ben Weeks talking about LaTeX to edX, and then Nate Ani talking about hosting edX with Docker.
Thank you, David. Hi there, my name is Ben Weeks, and wanted to talk about a tool called LaTeX to edX. So some of you out there might be familiar with LaTeX. It's a markup language that is pretty popular in academic publishing. And so LaTeX to edX is actually a tool that will allow you to translate existing LaTeX, actually slightly modified LaTeX, into edX XML. So through that, they use a compiler called Plastex, which is written entirely in Python. And this gives us some benefits, such as untethering us from the studio interface, giving us a deeper usage of the courseware. So actually, I think this is an old version of my presentation. Anyway, so we have an example up. The demo is available on GitHub, and the course content is actually available on edge.edx at the following URL. So what are the benefits? Well, in Studio, there's some non-human readable formatting of things like file names. Using LaTeX, actually, or any XML authoring system, you can determine your own URL names, which allows you to have human readable URLs in your course. And in addition to that, with LaTeX to edX, you can create either chapters one at a time, or you can create the entire XML course in one push, which can be beneficial depending on your course team's authoring needs. So to use it, there's actually one command that you need to use, which is LaTeX edX in the working directory of a currently existing course. I have an example further down the line, but just to do that, it's using about 5 or 6 macros in LaTeX, which will allow you to do everything you need. And what the Python script then does will, after Classics generates your XML, there's some XML features that will sort of make it a parsable for the import procedure. So, some common commands that you might use in LaTeX, such as the def command, which allows you to make your own LaTeX commands, is also usable, so that if you have either pre-existing context, then you can actually create your own commands that will override existing commands such as section or subsection to coincide with currently existing XML chapters and verticals and sequentials in that same paradigm. Additionally, this will give you an option to generate your course in a PDF, which right now the printing options in edX aren't entirely full featured. So this will give you another avenue in which to generate a printable version of your course. So there's just a small example right here of your course tech document, which is, as mentioned before, using some similar looking LaTeX commands, but then some of the other commands such as the edX chapter here and edX sequential and vertical are specific to your course. So we have our demo course. It's available on edge.edx.org. And if anybody wants to take a look at it, you're free to go online there and see what's available. And lastly, if anybody has a need to contribute, we're always taking submissions. So the things to make note of is that there's one style file and about 2 other files in which you can make your own commands and then propagate that to other people who might find it useful. At present, we support all existing X modules, but specific X blocks like open response assessment or staff graded assessment aren't yet available. So if you have any instructors who have LaTeX that pre-exists for a course that you're trying to put on edX, this is a good viable option. And anything that you want to do and modify, we are always accepting pull requests. So feel free to drop something by. Thanks.
All right, and next up we have Nate Audie.
Yeah. technical difficulties. Please stand by. Sorry about that, everybody. Okay, all right. Hey, everybody, how's everyone doing this morning? Awake? All right. So my name is Nate Ani. You can follow me on Twitter at NateA. And my talk is Open edX and Docker. And why you might be interested in this topic is if you're interested in low-cost hosting, shareable edX distros, and easier development environments. So a little bit about me. For a long time, I worked with organizations to help them with their content management challenges, and I was heavily involved in the Plone community. Some of you may have heard of. It's a popular open source Python-based CMS. And nowadays, I'm working with organizations in their online learning initiatives, and I'm doing a lot more with Open edX. So this is my son, Life, who is 2 months old. He doesn't always look this angelic, and he often keeps me awake at night. But last night, what kept me awake was my presentation. Something just wasn't right. Something didn't feel right about it. So at 4 a.m., I crawled out of bed and redid all my slides. So thanks, DB, for bearing with me. So here we go. So when I was doing the research for this report, making Open edX a thriving open source project, I interviewed a lot of people about Open edX. And I started to see some patterns emerge. And it really got me thinking about the spirit of open source. And Beth touched on this yesterday when she said that open source is a gift. And let me share an example in another thing we all like to do, eat. So let's say that your friend, okay, let's say his name is Ned, has invited you over for a fine sushi dinner. And when you arrive at his house, the table is set, the candles are lit, and when you sit down at the table, there's an amazing sushi meal, all prepared for you to enjoy. What you probably didn't realize is that for the last 3 hours before you arrived, Ned was slaving away preparing that meal for you. And he had to pull together a lot of ingredients in just the right quantities to make the sushi just right. And after dinner, you said to Ned, "That sushi meal was so amazing. Could I get the recipe so I can make it at home?" "Sure." But he adds with a wink and a nod, "If you make any improvements to the recipe, I want to hear about it." Well, Open edX is kind of like that fine sushi dinner, isn't it? It's a gift, but it's one that has some strings attached. It comes with a contract with explicit instructions to share. But it's not always easy to share your improvements. While we'd all like to think that Open edX comes to us like this, when we open it up, it looks a little bit more like this. So does this look familiar? The fundamental question that I couldn't get out of my head last night is this. If open source is all about sharing, how come it's so hard to share my improvements to Open edX? So if I take Ned's sushi recipe and I make a super sushi, can't I just package up my super sushi and deliver it to you as a sushi kit? So instead of the raw sushi ingredients, that would mean more people could enjoy my delicious sushi. So I apologize if this is making some of you hungry. I promise no more sushi slides. So Open edX is a complicated system with a lot of moving parts. What if you could package up all these moving parts, essentially snapshot your working edX site with all of your improvements, and then share that package with someone, let's say in Japan, just as easily as sharing it with your coworker? So this is where Docker comes in. Docker is essentially a way to snapshot your software and redistribute it. But here's what makes it different. It's not just the code that you're snapshotting, it's the entire application, including all the libraries and all the components that edX depends on. So you might say, "But Nate, we already have virtual machines that I can spin up using Vagrant. So why do we need Docker?" Well, Docker containers consume less resources and they're faster. While VMs consume a lot of memory on your machine and take a while to start up, Docker containers are very lightweight and spin up in seconds. So you're all familiar with these shipping containers, right? On those big ships that go across the ocean. You can think of Docker as a shipping container system for code. So the container is a standard format. You can ship things anywhere in the world, and they'll just arrive. You can put anything in a shipping container. The same is true for Docker containers, and they run consistently on virtually any hardware platform. So let's walk through an example to make this a little bit more concrete how it works. So in the last year, we built all these different enhancements to edX for different customers. Let's say that I wanted to share all these enhancements with you. I could send you the GitHub URLs, I could send you a long list of documentation to read, or I could just package all this up as a Docker image. So this is similar to an AMI if you've used Amazon Web Services. So I can give you my super OpenEdX. And if you're a developer, you can hit the ground running with a fully operational distribution of my OpenEdX site. And if you're a company, you can distribute this image to your customers, and they can run it anywhere. Amazon AWS, Google Cloud, Microsoft Azure, OpenStack, they all support Docker now, just in the last month or so. So the great thing about Docker images is that I can pull down your Docker image and make a few changes to it, and then I can push back my changes, and it only has to say the diff between those changes, not the entire image. So what GitHub is to Git, so is the Docker registry hub to Docker. So here's an example of a Docker registry hub listing for my company, Amazon. And you can see that we pushed a Docker image called edX Lite. This is the latest Aspen release, it was updated yesterday. So if you had Docker running on your computer right now, you could just run these two commands, and you'd have edX running on your machine in a couple of minutes. edX Lite is a pre-built image that's ready to it's already provisioned and it's ready to use. You can think of it like an appliance. No assembly is required. And Boot to Docker is a point-and-click installer for Mac and Windows that makes it drop-dead simple to get Docker running on your computer. But we wanted to make it so easy to try OpenEdX that you don't even need to install anything on your computer. We wanted to make the Steve Jobs equivalent user experience for someone totally new to OpenEdX who doesn't want to mess with AMIs, Vagrant, Ansible, and all the other things you know about. So Docker makes this a lot easier. Okay, so I want to try a little experiment. I want you all to take out your mobile phones and go to this URL. And there's a QR code for those of you with fat fingers. And I'll warn you, we haven't tested this with 50 people all at once, but let's try it. Everyone have the URL? bit.ly/tryopenedx. Got it? Okay. If you don't want to do it now, you can do it later. The URL will stay up. Okay. So if you were to bring up that page on your phone, you should see something like this. It's a simple form in which we ask you for your email so we can send you the URL to your OpenEdX site. Don't worry, we won't spam you. And if the demo gods are smiling on us, you should see a deploy complete message and a URL to view your own OpenEdX site. And this whole process takes 30 seconds. It probably takes you longer to type in that email address than it does to deploy OpenEdX. Okay, did it work for anyone? I see one hand. I see two hands. Okay, great. So the promise of Docker is that you can just take any app and you can deploy it to any hosting provider on any operating system. So imagine a world in which this is not true just for OpenEdX itself, but a variety of OpenEdX distributions that are for different audiences. OpenEdX for businesses, OpenEdX for K through 12, OpenEdX for learning to code, OpenEdX for Swahili, people who speak Swahili. Together, we can make this a reality for OpenEdX. There's been a lot of talk about letting 1,000 flowers blossom, but seeds need to be planted, nurtured, and watered before they blossom into beautiful flowers. Docker provides a fertile ground. It's great that we're sharing our code on GitHub, but let's not only share the seeds, but let's share the flowers too. Thank you. And I just want to mention that we're also doing, at the hackathon, we're going to be Dockerizing OpenEdX. We already have a single container. We're going to be making a multi-container one. So if you're interested in learning more about Docker, we'd love to see you at the hackathon. And if you didn't get a chance to try the demo, you can go to openedx.appsummer.com and you can get a free OpenEdX site to try. Thanks a lot, everybody.
Thank you to all of our great lightning talk speakers. We're going to have more lightning talks after the keynote. And everybody actually moves so quickly that we have a little bit of extra time. So if Charles Husband is ready, then we can start putting that together. Otherwise, we can give you all some time just to chat and hang out.
I'll just give the very briefest. Oh, yeah, we should set you up first. 1 second.
And I'm like that. Yeah, no. You just no. Nobody pressed the button yet. I saw that. I remember if that was back in like the corner. It doesn't matter. Like I just need to like we speak a live version. Yeah, I just get this. How do you? And you guys all know that they and how can you do it? How can you do it? And then you motivate. Yeah, I mean, I just really want to. Yes, push it. It just seems important. I mean, something
Talk accessibility.
Yeah.
So I'm wondering what your plans are. So at Stanford, we do this weird thing.
I not heard of it.
We did this weird thing where we do this audit. And then I'm going to wait for that. So stuff like and so I just put an NFT. It's not that hard, right? So this is not that hard, right? So I think it's valuable and Stanford, if the platform had NFT, then we can stop the misery for like their emails. We're trying to, and so what we want is for when what we want is we are able to take care of this even though things go wrong. We don't want to go so it'd be super valuable. So if there was someone else who was better, that'd be able to, well, I guess it's that's right.
So, so
I can probably make that one. Usually those items, yes. Oh, I'm not meaning to do it. I'm not meaning to type it. I know you. I'm not meaning to do it all the time.
So,
So, as a platform,
right, just do it. That's fine. So we are focusing. We're actually also no. I wish it was. However, you guys are on the quizzing table. You have a separate text file that if you're transferring all right. Good luck.
I'm going to be ready anytime you are.
Okay, I think we're ready to get started. I just want to introduce our next speaker. Gerald Sussman is here to give us some words of wisdom.
I don't know.
Professor Sussman is the Panasonic Professor of Electrical Engineering at MIT. He is perhaps best known for his research in artificial intelligence, but he's focused particularly on understanding the problem-solving strategies used by scientists and engineers for providing more effective methods of science and engineering education. Professor Sussman was also the founding member of the board of directors of the Free Software Foundation. Professor Sussman.
Hi. You didn't hear what I said yet. Anyway, about 50 years ago in September, I became a freshman at MIT. And I never left. Okay, so you get that kind of person that I am. Anyway, I'm an engineer and a computer programmer. That's two different things. And I think that the experience of being an engineer and a computer programmer tells me an awful lot about how thinking works and how learning therefore works and how we have to teach. I want to talk a bit about that today. I don't want to talk about the fact that the very important thing, of course, and the reason you're here is because there's advances in science and technology that have put you in a position where we can give educational benefits to the huge communities all around the world. But of course, everybody knows that, and that's not what I want to talk about. So I want to talk specifically about this. But one important thing is that the advances of these technologies are so important to our society that we have to be very careful not to get them tied up in proprietary restrictions like other kinds of things that have happened in the past. So it's very important that we have free software, and I mean free rather than open source, where free means free as in speech, not as in free beer, okay? I don't care whether it costs something. I care that it can be exchanged freely and that everybody can read it and write it and change it and give it to their friends. Okay, but in any case, let me start with an idea. Okay? Ideas are important, okay? Programming, which is one of the things that's the kind of engineering that I do a lot of, one of the kinds of engineering I do a lot of, besides electrical engineering or optical engineering or things like that. Programming is a linguistic phenomenon. It's like speaking your native language. Okay? And certainly after you've been programming for me, I've been programming since 1961. Isn't that wild? Okay, that's a long time. Okay, I've been programming so long that in fact it really is a natural language. I sometimes think in code. And the way to think about that is that there's basically, just like any other language, you can write prose, you can talk about the world, and you can write poetry. I mean, you can write things that are just beautiful. And certainly we do that all the time. And there are emotional consequences to good engineering. Really fine engineering makes you feel good. It's pretty. Okay? If it's not a beautiful piece of code, it isn't worth having. That's an important thing to think about in itself. Okay? But besides that, besides being a means of expression, what programs are, they're a way of clarifying ideas. I write programs for myself quite often, and what the purpose of the program is so I can be sure I understand something. Okay? I write programs for something that I found very difficult, like for example, general relativity type things. I'm worried about maybe how you really understand the differential geometry that turns into general relativity. So you write a lot of programs to get until eventually you say, gee, I know how to compute Einstein's equations. I know what they mean, therefore. The very fact that they're written in a form which is totally unambiguous, right? That's, even a dumb computer can understand it. Okay, that's when you really know that you've understood what you're doing. Okay? So it's in fact, it gives you insights into teaching as well. Okay, although the machinery that we teach is vastly smarter than our computers. Okay? That's an amazing thing. Okay, so the really powerful thing here is there's precision. We're required to be precise, and we're required to be unambiguous. And that's, by the way, not true if we're dealing in traditional mathematics classes. Mathematicians are terribly imprecise. I hope you all realize that. For good reason, they're talking in their native language to their friends. Okay, and so just like when I talk to you about in some English thing or something, what ends up happening is I don't have to say a few words, and that's because we're all almost identical. Okay? So a little copy of some data structure in my mind can be transferred to you fairly easily with ambiguous material because I don't have to be very precise. Okay? But that's not, and that's reasonable for something like a mathematician talking to a mathematician or writing a math book where they don't explain, they don't really understand how to write for people who don't know that stuff, part of their community. But indeed, you know, that when we're writing for computers, we have to be more precise than that. And that's good. Okay, so for example, let me tell you about some of the things you get in programming languages that you don't get in ordinary language. Okay, how many times have you ever opened a math book, okay, and you're reading along, and you say, my gosh, there's a symbol here, there's a phi. What is this phi? It just appeared. I have to figure out where it was defined. So I start paging back, right? And to looking to find out the first introduction, the proximate definition. Okay? Unfortunately, phi is used in 4 places in this book in 4 different ways. Okay? I might get the wrong one. And I have to, so that's a continuous process that's very hard. We have ideas in the computer business that solve that problem. There are things like scoping of variables. Right? We have let. You say let something, and in parentheses, and whatever kind of parentheses language you like. I like ones with lots of parentheses. Doesn't matter. Okay, but the fact is, we have languages where there are kinds of parentheses. Have the same problem in history. Which Edward Plantagenet we're talking about, which was the one that was murdered? There were 3 Edward Plantagenets who were kings of England. Okay, it happens to be the middle one who got murdered. But you have to be, if you're reading along, do you know which one you're talking about? They said Edward Plantagenet. Who knows? Okay, or you know, supposing you're reading a long story about a long story by Dickens. Okay. And someone's talking about the literary criticism, and they're talking about the unctuous man. Which one are they talking about? There are at least 2 in Dickens, and there are actually quite a few. But which one are we talking about? Well, the idea of referent, what the referent of a symbol is, okay, or a word in our natural language, is exactly a thing that computer programming gets us into much better shape for. So, for example, here's one. We have languages that have declarations with scope. Scope, and that's what I was saying before. You're looking here at a language that has lots of parentheses. There's one I like, it's called Lisp. For those of you who don't like parentheses, sorry, that's just a problem. But in any case, the thing that's important is that indeed in this scope right here, okay, is perfectly clear. I'm talking about this particular British monarch. I picked the dates to be ones which was, this is a British monarch who lived around the time when they changed from the Julian to the Gregorian calendar. And therefore dates are pretty weird. Okay? As a consequence, the date arithmetic has to be different. Subtraction of 2 dates is not ordinary subtraction. Okay? So in fact, what I specifically, if I want to know the lifetime of Mr. George II, I'd have to know that the particular lifetime was subtracted by the method called date arithmetic that's relevant here. Okay? And by golly, that gives me a scope where that makes sense. Okay? I could be forced to do that. And that's something I can't do in ordinary writing. That's a wonderful thing about computing is we've learned a lot. And in fact, there are some things that we already have. We have things like hypertext. Okay? Hypertext is a pretty amazing phenomenon, and we use it all the time. And Wikipedia is an amazing thing as a consequence. Probably the single thing on the network that has done more for my life than anything else is Wikipedia. Okay? What is it? It's an index into everything. And it gives me an index into the knowledge of the world. It's lots of things that are wrong, lots of things that are right, but the important thing is it's an index. Okay? And I really like that. So, but of course, part of that power is in fact that it's not a proprietary object. That makes it possible for people who know something that the authors normally would not know to add it in. Okay? Now, of course, that produces fights, people argue. Of course, that's the way societies work. But the really honest, good thing about this is that it's a community effort which has the property that people who know different aspects of something can add to it. Okay? And they can add to it without a lot of overhead. And you know what? That's why, for example, it's very important that we have things like free software, okay, and free communities of that sort. Okay. Now, another thing that happens with programs and with all kinds of engineering is that there are bugs. Okay? Bugs are wonderful. Most people don't realize that that bugs are for good reasons and they're good things. I'm going to be sure to explain this very carefully. You see, most people think about the reasons why we have bugs are things like inadequate specifications. That's true. Okay, kinds of things that occur in commercial software or perhaps highly used software that's used by a zillion people surely have bugs that are caused partly by the fact that it's not very well specified what exactly it's supposed to do. For example, specifications aren't anyway. Consider the fact that you have something like a chess program. It's easy to say specify that it plays legitimate chess, right? Legal chess. But how do you say it plays good chess? That's very hard. Okay. So we don't. There are a lot of things that are hard to say what that means, and therefore means of verifying the specifications are, no matter how clever those means are always going to leave openings. We don't know exactly what they should be doing. What about all the things that are undefined phenomena that something might fall itself into? Okay? When you write some piece of software or when you build some piece of hardware, okay, if you know exactly what it's going to be used for, it's easy to make it work. But of course, the biggest trick in the world is how do you know how to write stuff or build stuff that has a property that can be used in ways that were not intended by the designer or not even thought of by the designer? Wow, that's a big problem. Okay? And indeed, there's an entire whole corpus of work that's worth learning about that has to do with that problem in itself. But there's also things like unstable goals. Something that you built today for some particular purpose may be no longer appropriate tomorrow. And there are other goals that are appropriate for its use. And that's a different kind of problem. There are, of course, lots of things like unanticipated interactions, which are in fact the reasons why most bugs occur. But to me, the most important one is this, that problem solving, but that bugs are an important part of the process of powerful problem solving. Everybody who's building anything has to, if they're doing it effectively, has to make bugs all the time and fix them. Okay? And I don't care, the people who say you're going to specify with abstract logic the answer to your problem, and then you're going to make your program that's going to come out to be perfect, they're wrong, because that means you thought it out ahead of time too far. Much of the time when you're building something, a program or a piece of hardware or whatever, when you're building something, you don't know exactly what you want it to do. It's part of the process of discovery. Unless you're in some situation where there's a boss who tells you what's needed, okay, most of the time you're figuring out what it is that you can do. Okay, and therefore you're figuring out what it is that the specification will be after you're done. Okay, and that's a very different thing. Let me show you some example of this in a completely different subject, which most of you don't know anything about. Okay, you don't know anything about electrical circuits. I know that. Okay, how many people here are electrical engineers? Oh, good. So there's about 2 or 3 of us. Okay, great. Okay. Supposing I want to make a particular filter that looks like this. It's a bandpass filter. That means it accepts certain range of frequencies, another range of other frequencies it discards. Okay? An example of a place where there's something like this may be useful is a telephone. The original specification of telephones was that the frequency range that would be communicated with between about 300 hertz and 3 kilohertz. That's because all the information content in human voice is between in that range. That's very interesting because it turns out that your vocal cords vibrate at about 100 hertz. See, if you're a male, it's about 75, and if you're a female, it's about 125. Okay, but that's not, you don't hear that. That's not part of the sound that's even coming out of your mouth for the most part. You reconstruct it by listening to the harmonics. Okay, that's only the harmonic structure that actually carries the content, which is the shape of the cavities in your mouth and things like that. Okay, so supposing you want to make a filter like this. Okay, well, for those of you who don't know what I'm talking about, I can write a specification for a simple version of this filter, which contains something called 2 poles and a 0 in the complex plane. Okay. Any mathematicians here? Who's a mathematician? Okay, you know what that means then. That means I've got a polynomial with the roots, the numerator roots are called the zeros, and the denominator roots are called the poles. All right, so that's an interesting kind of specification, because what I've already done is I discretized the problem. I see that there are places where the poles might happen, and by golly, there's a 0 down here. Okay, and if I drew this in a log plot, it would be obvious, but I didn't. That I apologize. Okay, so then what happens? Well, I have a plan. Okay, I can take the system function, which is a ratio of 2 polynomials, and I'm going to factor it into 2 parts. Okay. Again, you don't have to understand what I'm talking about in detail to understand the idea. Now, I've taken the problem, I've broken it into parts. Okay? Each part I happen to know how to solve. In other words, and I also know, so I know that this part over here, I can make out of a piece of stuff that looks like that. And this part, I can make out of a piece of stuff that looks like that. Okay? Why? That's a different problem. I'm not interested in that right now. But I can do that. So as a consequence, I might have a plan that looks like this. I can say that compound system function, which is made out of the combination of these 2 factors, can be synthesized by cascading 2 pieces together. That's one way to build it. Another way to build it, I might want to say, oh, gee, I could make this into what I can apply partial fraction decomposition and make it sums. Okay, I can do that too. There's another way to do it. Okay? There are a variety of tricks. Each of these is its own little plan. The problem is this plan is wrong, okay, when applied to these parts. And I'll show you why, okay? The reason why is I hook it together the way I thought, and it doesn't work because there's a particular kind of bug that I've introduced. Now, I happen to know about that bug ahead of time. The reason why I use that plan is because it organized my brain, okay? One way to solve a problem is to jump into a hole and then dig your way out. Okay? And if you know how to dig your way out, that's exactly the right thing to do. So what happens is that I use a plan that I know has a bug called loading. That's the name of the bug. It's the same way as, you know what a fence post error is, right? How many people know what a fence post error is? Good. How many don't? Okay. How many fence posts are there in a fence that's 100 feet long?
How far apart?
They're 1 foot apart.
Sorry?
And the posts are 1 foot apart.
This is totally going to be a trick question. 99?
No, it's 101. You just had a fence post error. Okay? You have to have one at each end, right? That's the reason why it's next to one. Okay, that's knowing the name as every good sorcerer will tell you, knowing the name of a spirit gives you power over it. Okay? Knowing the name of a bug gives you power over it. There's an example called the fence post error in programming, or there's loading bugs in electrical circuits. Okay? Then for every subject I can get involved with, there are particular bugs with names. Okay? And you have to know the names of the bugs, and you also have to know the patches that are appropriate to fix them. Okay? So, for example, in the case of this particular bug, okay, what you do is and if you don't worry about the fact you have power problems, which I use since I use resistors, I don't. Therefore, I can put a little amplifier in, and that solves the bug. Okay? Again, why that solves the bug? This is not appropriate for this class. This is for the class I teach this afternoon. Okay? But the point is that the understanding of the concept of you decompose a problem into pieces, you find some abstract plan that's approximate. You instantiate that plan, and then you bring those pieces together, discover that it doesn't quite work, classify the way it broke, and then from that you have a new plan which says how you might fix it, test that, and you iterate that. That's a powerful way of problem solving, which we unfortunately don't teach enough to our students. Okay? You see, this, as I said, it's a powerful strategy. Okay? And very specifically, okay, I call it problem solving by debugging almost right plans. It's each plan is known ahead of time to fail in characteristic ways. For each failure mode, we have appropriate action we take to fix it, and this is applicable to everything. By golly, I have friends who are musicians. Okay? One of my friends is a concert pianist, and he's very, very good. And I've talked to him many times about things like this. He says, you know, a piece of art is a machine with an aesthetic purpose. Okay? And when you build some system, okay, maybe a system which is some piece of music that you're building, or it might be a piece of poetry, or it might be a mathematical theorem, okay? There's always rough edges when the pieces are brought together, and you have to fix them. You have to figure this out. So debugging is the essential idea, in fact, a lot of our intellectual processes. Okay? But unfortunately, we never teach that explicitly to our students. We don't use that idea in our teaching, and we really have to. And now we're at the opportunity, we have the opportunity, because we have a chance to change the way teaching is done, okay, to begin to think about these kinds of powers that we now have, that we've had all along, but we were never explicit about them or specific. Okay? We didn't understand them well enough until we got into the engineering of these things. Okay? So for example, if a compound mechanism, here's one piece of stuff that you might have to know. If a compound mechanism fails, like for example a poem, there's a beautiful paper by Edgar Allan Poe where he explains how he wrote The Raven. It's called The Philosophy of Composition. It's online. You can get it. Okay? Spectacular paper where he explains that he's trying to make a particular emotional impact in the reader. He takes the various parts, puts them there. He explains where they're broken and how they have to be fixed and patched. Okay? It's a great paper. And you'll see that's exactly what I'm talking about. Anyway, okay, so if a compound mechanism like a poem fails to have the behavior that was intended, there are two ways that can occur. Some parts don't do what they expected of them, or either connect to the parts does not correctly achieve the goal. Okay? So how do we debug students? I know that there's a lot of pressure in the way we think to say, okay, we're going to use statistics. We're going to look for patterns by correlation, and that's true. That works to some extent, but understanding what's going on inside the student is not quite that. Okay? Figuring out why the student has a problem. One beautiful example I've had in my teaching is many students, even at MIT, when they come to take a class in electrical circuits, turns out they understand a lot of stuff, including all sorts of abstract mathematics. But you sit them down, they have to solve 3 simultaneous linear equations and 3 unknowns, and they go into an infinite loop. Okay, happens. Okay, now I get one of them in my office. Okay, I say, okay, do it on the blackboard. Okay, almost always the way they fail is they forget to back substitute into one of the substitutions they've already collected as when they're sitting there. Okay, and then of course they use that substitution and it still has the old variables in it, and that happens. So the fix and the patch, and it's easy. You fix the student and they fix for good. All you have to do is tell the student, organized. Okay, you write this down here, you write down the sequence of substitutions you're making, and every time you get a new substitution, you add it to the bottom of the list. You look for any variable above that that contains that, cross out that substitution and replace it. Okay, you do that, and the student never got that problem again. They're debugged. Okay, we can do. What was that? Right, okay. Well, you see, the fact is, we should be doing this in the software that we use for teaching as well. We should be thinking about that sort of thing. Okay. So that's the sort of thing I want to understand, and I want us to go down that path in the way we think. Okay? Then there are things. What is this kind of thing called a plan? We're talking about plans. Okay, a plan where you saw one I showed you, which was the cascade plan for an electrical circuit. That's a filter maybe, but that's not so important. What is a plan in general? Imagine that you're an architect. Okay? They have a thing called a partee. Okay, and the partee is this sort of, I suppose the guy Kahn, the famous architect, sort of figured out the idea that there are served spaces and server spaces, meaning the things that actually people are using, like a room to live in or a room to be as an office, versus the hallway that feeds that office and other offices. Okay, that's the server space and that's the served space and the server space. Okay, there are things like where do you put the elevators? Okay, where do you put the HVAC equipment? Okay, all that stuff is not really in the basic idea. That's the idea of the thing you're trying to build. And what the old days, what architects did, I hope they still do to some extent, is they draw a big partie, a plan that's, and maybe they make a little model, but they build something that couldn't really work because it doesn't have any of the details, but it's sort of an overall layout of the shape of the space. Okay. Then they used to use plastic sheets and put them on top. Now you draw in where the HVAC goes. Here's where the water lines go and the sewer, the waste pipes. Here's where the whatever goes. You put them one on top of each other. You have this pile of sheets. Okay, that's the kind of thing that we learned about in engineering a lot and stuff like that. And guess what? We don't teach students that really very well. We don't teach them the idea that there's an abstract, very simple plan underlying everything. And if there isn't one, it's a screwed up mess. Okay? So for example, here's a beautiful example of a problem that occurs even in programming. Okay? Supposing I'm writing a multi-step numerical integrator for second order systems. Again, how many people know what I'm talking about when I say that? Okay, about 3 of us, right? I'm sorry, I happen to be a technical sort, so I'm giving you technical examples, but I'm sure I could find ones from other subjects. Okay, so what you're seeing here is basically an approximation to a second derivative. A discrete approximation is something like a square root of step size times the sum of weighted sum of accelerations. Okay, that's exactly what a integrator might be. And so this is a very complicated sort of thing, but it's actually a very simple plan. For a person who's a numerical analyst, it's the obvious plan for some kinds of integrators. Stormer's integrator is an example of this. But now you look at something like this and say, oh yeah, but there's something special here. This subtraction and this addition are special. They have to be done in higher precision than all the others. All the ones inside this sum, or these, and this, those don't matter. Those can be sloppy. But these two have to be absolutely precise. Sorry, this one and that one. A bothering machine. Okay, I don't have one. I don't even have a cell phone. I don't want one. They follow you around. They spy on you. They tell everybody where you are. I can't deal with that sort of crap. But in any case, one problem is I would like the way we think to say I lay out a partie. That's a partie. Okay. I then want to lay on top of it a sheet which says, oh yes, double precision here and here. Okay. And a reason why. That's because h squared is small. Okay. Things like that. Okay. So that's the sort of thing that is a difference that I'd like to be able to say, and I want to be able to somehow teach people that idea too. The way we teach ought to be in terms of laying out plans and have the students understand that so that they can do that too. Okay? Our main job is to teach students how to be like us. Okay? And that's a pretty hard job, I think. Okay? Do we have the skills of planning? I'm not sure. Okay? There isn't at this time a very clear theoretical basis. That's one problem. So maybe it's worthwhile working on that. Okay? Do we understand much about how to teach planning? Well, I don't know. A lot of my colleagues say it's hard to teach design. I don't feel so bad about it. I certainly tried, but I think it's the case that there's generally we don't know how to do that, okay, as a community, and that's important. Another thing is do we have technology to support teaching design? Well, we have a start because we have computer languages. Computer languages, because the things we build have a million parts, which is worse than almost anything else we ever build, more complicated. We've been forced to learn how to organize better. We've been forced to invent things like let, okay, like local variables with appropriate bindings. We've been forced to think in terms of absolutely careful precision as to what how we speak. I think that we should begin to use some of that technology in the way we actually write our teaching too. I would like to see intelligent books that have the property that they're scoped, okay? That the symbols are appropriately scoped, okay? That they can give you an argument as to why something is true, okay? Not just that they can tell you the answer or say you're wrong, but that they could actually say, and here's why, and I'm making up a new argument because you asked it the first person to ever ask it. Okay? And of course, that can be assimilated into the book, but that's a separate issue. Okay, so I'd like to see things like that. Okay? Okay, so here's my overall moral. I've probably talked as much as I'm going to. We really don't know much about teaching. I believe that's the case. We don't know much about learning or much about thinking. But one of my teachers, Seymour Papert, taught us one important thing. Programming and engineering give us levers for this. Okay? But the lever is not only the lever that you've been thinking about here as being the way you distribute the information. The lever is that there are ideas in that stuff. That's powerful for every subject. Okay? And it makes people smarter. Okay? I highly recommend reading Seymour Papert's book called Mindstorms. Which is well worth understanding that. The other thing is that in a world that's so foggy, what matters is that we work together. It is absolutely critical that we don't succumb to making things proprietary and separate, where one person sort of owns something that he can't, that somehow doesn't give away to his friends. This may be important in building things like automobiles, but it doesn't sound to me like it's the right thing in teaching. Teaching is something for everybody, and yes, indeed, I know they got Socrates to poison himself over this, but so this is the story. We must indeed hang together, or most assuredly we shall all hang separately. Mr. Benjamin Franklin. Okay? And that's it. That's all I have to say. Okay. I'm happy to answer questions. I'm happy to pick fights. Anybody would like to pick a fight, I'll be happy to talk about anything. I think we have some time for that, right? Yeah. Yes, sir.
Well, you've certainly given me some excellent ammunition. I watched.
Would you like to stand up so that people can hear you? Yes.
Thank you very much. You've given me excellent ammunition. I found myself in debates with watching the discussions. I've given up trying to debate enterprise architects, and their work seems to stop the delivery of the plan. I guess the assumption is the plan is perfect.
Oh,
Thank you. Exactly.
Right.
So if the plan is useless if it goes on the shelf, if it moves forward to making something, program, whatever, then there's going to be bugging because the plan is wrong, needs modification.
Sure.
Thank you.
Okay, well, yes. Anybody else? Yes, sir.
I really like your fiction on using debugging and learning, but can you maybe have some ideas already? You're already talking about books where people can add like a why. Sure. Do you have maybe more of those ideas?
Yeah, of course. There's a whole bunches of things like that, and if you're willing, I'll show you a fun thing, which unfortunately only electrical engineers will understand. Right? I have one slide here. Right? This does not appear. This will not appear on the exam. Okay. Okay. Here's a thing that looks complicated. It's extremely complicated. It's a low fidelity amplifier from a sort of an old radio or something. Right? It's an audio amplifier, and I'm going to demonstrate to you that you don't need any equations to understand what to do. Okay, to understand how this works, and there are techniques that we can use to avoid having to do any algebra. And I'd love to show you this, and nobody writes these down in books. And the reason they don't write them down is because it's too hard, okay, in English. to write it down. But a program to do what I'm about to do is rather simple and easy to write in a modern computer language. Okay, I'm just looking for something that makes it easy for me to know the answers. Well, I'm not going to know the answers because I can't do arithmetic in my head. Okay, but what I'm going to show you is this. There's a concept called propagation, which has to do with knowing how, seeing locally some information and using it to deduce other information. Such that when you build a diagram, it doesn't matter what the diagram is. You build a diagram, you can use the diagram as your memory. And you write on the diagram things that you deduce, and that helps you deduce other things. And we do this all the time in every subject we ever deal with, including things like abstract mathematics, where you draw, all sorts of diagrams that look like category theory stuff with arrows and lines and whatever. Okay, you walk around these diagrams. So here's the thing. Okay, supposing I wanted to do an analysis of this amplifier. Now, I can show you, I'll do a DC bias analysis in no time at all. Okay? That means the first discovering all of the states of all these parts, what the currents and voltages are on them. Okay? I'm going to do it. I'm not going to write down the numbers because I don't have them in my head right now. I looked for my notes and I didn't have them. But here it is. Okay. I happen to know that there's a 15-volt power supply from here to here. Okay. I also know that for doing DC bias analysis, again, you don't have to know the words I'm talking. That means that there's these capacitors are open circuits, and I don't care about that. Now, also, I'm going to assume, but I have to check, that all the transistors are in the active linear region, which means that they are forward biased. There's no current approximately going through their bases, and there's about a 0.6 to 0.7 volt drop between bases and emitters of these transistors. That's an assumption. All that has to do, those assumptions have to be tested later, and there's ways of testing it. Now, under those circumstances, I see this is a voltage divider. Since I know the voltage here and I know the voltage here, I know the voltage here. This voltage has 0.6 volts down to here, 0.6 volts down to here. That's 1.2 volts from what I deduced. That gives me a voltage from here to here, which gives me a current through here. That current must be coming through here because it can't be going out of a base of the transistor. So that means since I know the voltage here, I know the voltage here. Given that I know the voltage here, I know the voltage here is 0.6 volts below that, so I know the current through here. That current must be going through here. That means I know the voltage here. Therefore, I know the voltage here is 0.6 volts below that. Therefore, I know all the currents. Okay, so forth. Now, what you saw though is locally looking at something and propagating information around. This is a hell of a thing. We don't teach this to students because you can't write this in English very well. See, the general theory, the general program for doing this is very complicated. The program that we teach them is something called node method, which is horrible because it's a bunch of equations and you have to solve them, and these are nonlinear exponential equations, and you can't do it. Okay, so you get a computer to do it for you, maybe approximately. Okay, but now the important thing is I have to check what I did because I have certain assumptions. So I know that the beta of these transistors is about 100. So therefore, the base current is about 100th the emitter current. So if I said there's about 10,000 here, so that doesn't change the voltage here very much because I know there's how many milliamps are going through here. So basically, all my assumptions were right. Now I'll show you how to get the gain of this amplifier. Well, it's easy. Okay. Now my capacitors are short circuits for my signal. Right. So if I go twitch here, okay, put in a change in voltage. That change in voltage appears here. That propagates down here and gets down to the same twitch. That increases the current through here by the size of the twitch divided by 1.8K, which gives me a change in current here, which is multiplied by 10K to give me a change in the voltage here going down. In other words, this switch going up causes this to go up, causes this place to go down by 10K over 1.8K. Same thing happens here. It's 5.6K over 3.3K. So the total gain of this is 10K over 1.8K times 5.6K over 3.3K. That's it. And I'll get you that. The answer is going to be accurate to 5% independent of what these transistors are. Okay? Now, that's the sort of thing that I'd like to be able to teach students to do. Okay? I'd like to be able to have them understand enough software type things so I can write the program and give it to them. And they can read it. You see, because a program is a thing to read and understand. It's not just something to get a computer to do something for you. Right? It's a language that carries your intent, your expression, and I can write a program that in general does this kind of thing to the extent it can. There are certain things you can't get this way. If I have complicated feedback loops, I may need to add some equations occasionally, okay? But there would be very few of them because most of the stuff gets done this way. So I'd like to be able to put together better stuff, okay? And I think that's the kind of thing that I'm trying to push in this talk. Anything else? Yes, sir.
It sounds
Stand
like,
up so that people can hear you. Mhm.
I might be further for people standing up than sitting down. It sounds like a lot of the things you're saying about the learning book and things like that. To me, that reads like taking the advantage of the interactivity that you get with a tutor versus a lecture and scaling that through technology.
Yep.
And to me, that points to an intersection with artificial intelligence and machine learning, or is that overthinking it? Is that more complicated than?
Well, there's 2 parts to that. Yes and no. Right? Yeah, what I've been talking about is what the old kind of artificial intelligence is trying to figure out what it is that actually is happening. Machine learning is trying to get correlations clear. For the most part, machine learning is advanced statistics. Also useful. Okay? I'm not saying something bad about that, but there's another thing, which is interpretation. It's determining what it is that's actually the reasons why things are, and can you give someone an argument? And that's slightly different. Okay?
I've seen.
Yeah.
I'm sorry.
Yeah, go ahead.
I've seen I've seen tools out there that approximate that mostly through like dumb string matching and things like that.
Right.
Is there anything in particular you think is on the bit? What's the next step? Is there a project that I should check out if I'm
Well,
interested in seeing it?
there's a lot of stuff that's been around for a long time, like software that does what I just did, okay, that I can give to you to read. Okay, that's a sort of thing that, you know, is fun to do. But whether or not that ever gets into the mainstream educational technology is not apparent. And so that's why I'm worrying about that. Okay? So that's in very specific subjects where there's well-defined. The nice thing about circuits, which is why I use it as an example, is it's about well-defined things that are connected to their neighbors by well-defined methods, and with very few interconnections. So such things, this is a powerful technique here. But you know, for everything, there's something like that, and there's got to be a lot of coverage of particular ideas with little patches of how knowledge works, and we should fit that together into a way we can teach. We should be also being able to let people read that stuff in a way that they can assimilate it by reading a good piece of text. Yes, sir. Can you talk a little louder? Yes. I'm actually worried about that. Giving people a lot of very immediate feedback is useful for getting them to learn facts and often to help them out of bad holes that they get into, right? But the difficulty is not forcing people to actually fight with a problem, you know, where there's stress, okay, and they have to come up with an interesting answer that may take several steps. That may actually be something we lose by turning this into something a stimulus response type game. I don't think stimulus response is the way we want to teach. It's good for rats, but it isn't very good for teaching your students how to be smart. And what I care about is I want our students to be smart. Yes, sir. Yes.
It seems like some of the stuff that you're describing has a lot of relationship with how novices see experts, and the way that for an expert, the task that we give to a novice is easy for us, difficult for them, and so they ask us how to do it. We just sort of fly through it, and so they think that they're just going to fly through it. So they're good at it.
sounds like there's a connection between stuff you're talking about debugging and how novices and experts. Does that seem accurate to you, or?
To some extent, the crucial thing here is how do you get someone to become an expert, okay? And I'm suggesting that there's another thing we can do that we haven't done, which is to tell them in some explicit way what it is that an expert actually knows. Okay? And that in many cases is complex procedural information, which is not available as facts or simply written statements, but can be expressed, for example, as fragments of computer programs, fragments of I don't care if it's written in some special language for the purpose, but something that the students understand that can capture that information. Is there anybody else want to say anything? And I'll just sit down. Okay. Hope that was helpful.
I want to give a big thank you to Gerald Sussman, and thank you everybody for dealing with the fact that we don't have a wireless microphone. Appreciate your patience on that. We're going to take a break and we're going to start the lightning talks at 11. If you signed up for a lightning talk, DB's right here. If you have slides, you might want to get them to him in advance. Thank you.
Hey, how you doing? What have you missed? I came here this all resisting
Which is also why
I haven't been involved as much in the standards wise except for
So it sounds like there's a break now for about 25 minutes.
And I can't yeah, plot twist, that's just great. You know what? Yeah, I'm just, No, it's not. Yeah, I have a hard time justifying $8 as a thing for one. Yeah. Yeah, actually, that's actually it's like it's actually not that
Yeah, there's somebody that goes, I know you're yes, yeah, it just, if I would have, like, asked me if I wanted to do 10 minutes like yesterday, I would just, I'll do 10 minutes. And then also, just have a certain amount of time, like, 10 minutes, like, honestly, more.
Got it.
Just like find a different place to stand.
I thought it's, just go away sometime. I wasn't sure whether it was a C or 2 was carbon monoxide around. Then it went on and on, announcements started, I picked up my laptop. Something, I didn't find out what it was. My friends were there. Yeah, good morning everyone. I took off my schedule, breakfast time and all of that. But it says, there's something going on, like every time I do something, these happen. And now I know who the customer is. No mic, but I can read it.
So Kim was thinking that if he can vividly talking. Oh, thank you. So thinking that we want to see if PDF solution matter or whatnot, have the practice on and then we think that's what I was studying. That's what I was studying.
Like guys like I mean, I can still investigate the thing. I don't think it's
and that's what we'll be doing for my thing. Go investigate and then we can book a trip. I don't know why it's not a long maybe. Might book a trip again. And then come down and
yeah, I think the fact that having their engineers on the hand, a chance to build deeper relationships.
That's what hobby again, or
Yeah, I mean,
yeah, you could have plan, like, yeah, you could have planned it beforehand and start, you could have not allocate himself to this trade.
yeah, well, we'll make it sprint 11. What's on the hopper for 10? Yeah.
We're doing a new BI feature on Azure and using big data.
Okay.
So that's we have to stand up this big infrastructure on Azure. And that does not have a whole lot of support in Azure. So that's like a challenge right now.
Yeah, I tried using it. I did a Hadoop use course. I tried using HTTP side. I thought, okay, this is not really viable. So thanks for thinking through it. I mean, it's good offer to have.
The other thing we can do is we can go and like I can put the end of the meeting and now we can start on an opportunity for marketing team to traffic so that people don't know what on.
Hi, everybody. Just we're going to start the lightning talks in about 5 minutes. About 5 minutes, start the lightning talks.
This event starts in place. People building that solution. Is there an alternative way you can take it? It's time to market.
I didn't know the password, so I.
Password is edX.
For your laptop?
Oh, for my laptop? No.
Your laptop is
Yep. All right, everyone. The lightning talks are about to start. If you could please sit down and finish up your conversations. First up, we have Felipe Montoya. Okay. Can everybody hear me? Yes. All right. Please sit down, finish up your conversations. The lightning talks are about to begin. First up, we have Felipe Montoya. Next up, after he's done, is going to be Joe Blaylock.
So, hi, can you hear me? Okay. So yeah, I wanted to talk for a really short moment about a really nice feature that the OpenEdX platform has. It's called microsites. Some of us are talking about it, and it's a really nice way to get white label sites powered up rather quick. So I'm just going to go straight to the usage on how you get this running. So on your dev stack, on your AWS environment, on your LMS authentication or environment JSON, whatever it is that you're configuring it, you need to power the use microsites feature true. And then you define an array of variables that are only for this microsite. I'm here defining a microsite called Pakua, and this has just some global variables where what the name of the platform is, what the logo of the platform is. Further on, the email address is going to be sending the emails from or sending the payment support from, and so on and so forth. And then you configure all this data, set the use microsites true, and go straight to the usage. I saw Chris Dodge a minute ago. Thanks for doing this. He developed the feature initially, and he made sure that it works on a big part of the platform. Complete is not support is not complete, documentation is not complete, but it's coming along the way. So you can start using it on your templates, either the Mako templates or the Django templates. Just load the feature. And same on the views, just load the microsite feature. And anytime you are on a template or anytime you are on a view, you just call it. You try to get say, any variable you loaded for this particular microsite, or then you sort of default to the regular settings variable that was defined globally or the default setting for that. After you get this done, you can load you can load specific templates, you can override templates, and you can override the look and feel of those templates through CSS. All of these configuration variables that we're using here, we are using them now on our production server. And just to give you an example, it looks like this. This is a complete site that is powered by our site. The URL is different, and they load a complete different set of look and feel and specific templates for their operation. It goes through and through to the courseware and to all the specific sections. The player is the same, but otherwise we alter the look and feel quite a deal. But it doesn't have to be this complicated. It could be just the basic color or the basic themings. I forgot to say this also. This feature also supports defining a subset of courses which will be displayed on said microsite. So all these sites that you're looking now are actually the same installation, same server, but they run with a different look and feel, and they display a different set of courses for each one. This takes a couple of minutes to set up and almost nothing to deploy. It's already on the platform. So yeah, just wanted to show a bit the way we're using this feature to power white label initiatives. So it's a really low cost and it's effective to get almost a new platform, but with the resources you already have. Thank you very much.
All right, now we have Joe Blaylock, and up next is Stephen Birch.
You don't even have F keys. How does this thing work?
Is it F5?
I think so. Yeah. Oh, there we go. Oh, nice. Okay. Yeah. I guess people can hear me. I can hear me. So this is just a quick, mostly an FYI and an invitation to conversation. It's come up on edX Code a bunch of times that people want some way to do self-service or rolling or continuously deployed certification for students. And there is such a thing. We built it for Stanford's continuing medical education program for accrediting the doctors. And it's a little, it still needs some setup and it still needs some polish, but it's there and it mostly works. And it looks like this. Internally, we call it the grade me button. You just have an HTML component at the end of your course that has this blob of JavaScript in it that can post to a REST endpoint, which has already been merged. And when students hit it, they get graded. And if they pass, then they get in-queued to have a cert created for them, which then appears on their dashboard a few minutes later. So to have this, you have to have a working certificates pipeline. You have to have all of Stanford's changes to the certificates pipeline, which merged 10 minutes ago. And then you set up some settings. On the advanced settings page, you set the certificates display behavior. That's the most important one because otherwise you won't see the certs appear on your dashboard. They'll generate, you just won't see them, and then you'll be confused. So you set the certificates display behavior so that you know that you got something. And then you put the grade me snippet into the HTML component on the course. This is currently a little bit of a hassle, and you should contact me to get the snippet or just search edX code. I've pasted it in there probably 5 or 6 times. We want to get a YAML template merged. It requires some documentation that doesn't exist yet. Or even better, we'd love to get an X block built by somebody. It'd be like a trivial little X block to do this. We just haven't got around to doing it yet. The main problems with it so far are that there isn't a YAML or an X block for it. So right now it's sort of cut and paste setup, which is a little bit of a hassle. Maybe that'll be fixed this week. Hopefully that will be fixed this week. And then the other problem for edX.org, and not for the rest of us, but for edX.org, there's this problem of asset management that you have to make sure your certs are ready to render before you set up the grade me button. And that's a problem that's not a problem for the rest of us because we have course operations teams or we have people who actually deal with this stuff that we can talk to. They organize stuff differently and they need something that scales better. And so we've been talking about building self-service asset management for building certs. That's a little further away from being done. But that's basically it. Mostly I just wanted to say there is this thing. If you want to know about it, get in touch. And I'm gerbil everywhere. And feel free to send me email or find me up and sitting in the back of the room. So that's it.
Now we have Stephen Birch and Justin Goodhue next.
All right. Yeah. Nope.
Microphone? Cool, here we go. All right, so I'm Steven. I'm a full stack engineer at Stanford. And when I'm not evangelizing about JavaScript, I like working with Xbox. And we've had a number of things that at Xbox we wanted to create. And some people have talked earlier today, yesterday, about the process to do this. There's a workbench, an SDK, as well as some templating scripts that try to streamline this process. That said, they're less than ideal, at least I've found. So some of the problems are, so we look at the default student view, the default view that people are going to find. The CSS is included inline on the page. The JavaScript is included inline on the page. And this is a performance problem because this means that these blobs of static asset are pulled down each and every time we load these pages. Multiple times there are multiple X blocks. Aura 2, the Aura 2 X block is a particular offender here. Last I checked, I think there are about 200K worth of static assets come down across the wire every single page load. And that's a performance problem. This is then exacerbated when we look at the actual content that's coming across the wire. By default, this content isn't minimized, or it's not minified, and so we have just more data coming across the wire than we need to, more often than we need to. Beyond that, a couple just some more smaller things. Some of the directory structures a little bit was confusing for me at first. So there's a static directory, which is for public content, and then for private content, and then there's a private directory, confusing. I'll leave that to it. But anyway, so for me, it took a little bit to get my head around. Beyond that too, there's a concept of a studio view where you can make edits to an X block, and the template doesn't generate that for you. And that's something that would be nice to have by default, but it's a pain to create every time. So the solution here, so working with creating a Docker container and a little bit of syntactic sugar with make, we're able to really streamline this process and really establish some of these best practices to just work out of the gate. And if this video will work, and it's probably not. Failed. Cool. So now that your curiosity is maybe piqued, oh, really, I hope so. But anyway, so what we see is essentially with some really simple targets, you can type make X block, and then it spins up a fresh Docker container for you, and then from there, it's going to prompt you for some basic information, metadata for your package, the name of your X block, author information, things like that. So it's easy to publish to PyPy, to NPM, depending on what your use case is there. And then it spins up, will create that X block for you, and then just simply then typing make will now then spin up that Docker container again, install your X block into your working environment, and then have a host automatically listening for you. From there too, one of the big components is using Grunt as a task runner, and then monitors all of your static assets while the host is listening. So any changes to HTML, CSS, etc., are then instantly linted, rebuilt, compiled, etc., etc. So it's something that you just don't have to think about. It behaves transparently. And so this has worked pretty well. You see, we have a pretty straightforward directory structure here. One of the big highlights too, so we also has a default setup for Travis for continuous integration, so that it'll at least automatically run linting and everything, and it's really easy to hook up through GitHub if you haven't done this kind of thing before. So what this leaves us with then is we have fewer HTTP requests being made. Each of those requests end up being smaller as well. It also generates map files for us so that it's easy to debug these minified files in the browser as well. The files are loaded externally. They can be cached. The build pipeline is transparent. It's something you don't have to worry about. It just works. Where you get a default studio view for free so that you can make changes right there within the studio. And it even generates a README file that gives you a to-do list for the additional tasks that you might need to do to follow up and polish. So if this sounds interesting, if this works for your workflow, come talk to me. If not, feel free to fork it. Thanks.
Now we have Justin Goodhue, and next up is Dee Kanagia.
All right. How's everyone doing? Woo! Awesome. There we go. So excited. I like it. So my name's Justin. I'm from Accredible, and we're trying to make online learning increasingly credible.
So the goal of this 5 minutes is really just to impart some thinking for you guys as you're thinking about credentialing and accreditation. There's been a lot of talk about this, and I know there's some talk coming up. So I just wanted to just touch on this quickly for 5 minutes. So before I get into it, the way we learn is changing. Everyone in here knows that. I like to say that I could be in the middle of a desert in my PJs, and I could be learning from the best people in the world. Or I could be in Boston wearing a crazy flowered shirt as well. So with that being said, credentials need to evolve as well. So we are still giving out a PDF certificate, and that is what we're all working towards. We're, as providers and as learners, working towards getting that certificate or giving out that certificate. So we really believe that this needs to evolve. So we have 5 principles that we based our certificates on, and I would like to pass that thinking on to you guys. So the first is scalable. Right now, it shouldn't matter if there's 100 people in your course or 100,000 people. Right now, a lot of the credential is based on a brand credential. So if you go to Harvard, for example, you receive a very good credential, a very good certificate, but that's not scalable. It's based on scarcity, so we need to create a certificate that isn't based on scarcity and is scalable. So that's something to think about. The next is it needs to be flexible. So learning right now traditionally is a 4-year degree. If you do 3 years, you don't get that certificate. We need learning to be a lot more flexible. So when you're creating certifications, it needs to be flexible. It needs to highlight what the learners have learned, whether they've done the whole course, parts of the course, and they're gonna do it at later times. And that brings me to my next point, which is ongoing. So right now, learning should be ongoing. Everyone is a lifelong learner. Everyone is really excited about learning. They want to add and they want to keep on building upon what they learn. So you need to make a certificate that allows people to do that. And we believe that learning happens everywhere. So you need to make sure that a certificate can showcase all that different learning, whether it's watching a video, whether it's using learning on a MOOC, whether that's in person. It needs to be available and be comprehensive because learning can happen in many different ways in this new education that we're looking at. And lastly, it needs to be aspirational. We really believe that we need people to get excited about certificates, and we don't want them to be looking at the light at the end of the tunnel being a scary light where they have a certificate where traditionally it starts at 100% and you start getting docked off marks. We do believe there needs to be marks and standardization and things like that, but that's something that you guys can decide. What we want to do is give someone a certificate right at the start so that they can build on that certificate and they can get excited about it. So it's not just a PDF. It is a piece of paper with evidence that is based on what they've learned, and they can build and they can grow from that, and they can be excited and proud of it. And we can start pushing this movement that we're all here for forward. So we create certificates for the new online age. If you're interested in talking to me about it, I love it. I'm really passionate about it, and I would love to talk to you about it. Here's some quick screenshots. We just created an Open edX plugin so people can start providing certificates today on the Open edX platform. We have an API, fully customizable design to your course, and the best part, it's free. So please come see me after. We are Accreditable Certificates for the Online Age, and my name is Justin. Thanks a lot for listening, guys.
All right, next we have Dee Kanagia, followed by Julie Mullen.
Hello, everybody. My name is Dee Kanagia, and I'm the founder and CEO of Cogni. Cogni provides natural language processing-based virtual learning assistant for online educational platforms. My background is that I have done PhD research background in speech recognition, natural language processing. Used to work for a startup here in Harvard Square called Blingo, which was the first virtual assistant for the smartphones, and later on it became this S-Voice technology on the Samsung Galaxy devices. So earlier in the talk, Gerald gave us a very nice overview about the planning-based learning and education. And one of the elements he emphasized was that the programming languages have two attributes. One is that it is precise, and the second is that it is non-ambiguous. Unfortunately, the learning generally takes place through the natural language conversation, and it is both imprecise and it is ambiguous. How can we solve this problem and make learning more effective using technology? So if you know, online education is booming, and there are mainly three elements. One is there is a platform such as Open edX, then there's a learning content, and the third part is the assessment. Assessment has not made much advancement. There are very limited choices available to developers currently. Either they use automated systems like multiple choice-based assessment, or they use human-reviewed assessment. Cogni provides a third way of using natural language processing technology to do the automatic assessment of short essay answers. Now, many of you might already be familiar with the ORA, Open Response Assessment, inside the Open edX platform. And we are currently in the process of integrating Cogni's solution to enhance that functionality. So here would be a screen where student would be asked a question and they would be typing a response in natural language. When they submit a response, such as what is musical harmony? Harmony takes place when more than one notes play together, and they submit. They get instant feedback, which is qualitative and helpful. It provides hints if they are missing something. And based on that, they can update their answer and learn the topic. Here is another video of how actually it works. So a student is learning about engineering mechanics, and in particular about highway bridge design. And there's a question about why the splice is put at a particular place. So when the student would click assess their knowledge, they would be typing a response, and the system would provide a live real-time feedback. So it says it's a good start, and yes, you're right that there is no moment at the location. What about the moments? And based on those responses, the feedbacks, the student submits additional components of the answers, and the system keeps providing them feedback until they learn the topic. Now, what are the differences between the edX ORA and Cogni? So ORA uses a technology that is primarily machine learning. Cogni uses a technology that is primarily natural language processing. In answering one of the questions, Gerald mentioned that the machine learning is trying to focus more on the correlation, but the importance is that we need interpretation, and that is possible through natural language processing. Generally, you need many samples before the ORA can be put to use. We generally require less samples. And the output that machine learning technology would produce is a prediction of the numerical score a student would get. On the other hand, we provide qualitative feedback. We also provide real-time assessment, and it's ideally suitable for formative learning and assessment. We enable subjects in very variety of ranges, from music theory to security. And we work with developers to providing a RESTful API that is very easy to integrate on the backend. So here is an example. They could use a RESTful API to submit their assessment requirements, and we provide numerical score as well as a feedback that they can display depending on whether they are doing formative or the summative assessment. We are going to be working on creating XBlock as well as LTI plugins. And we welcome anybody to participate during the hackathon. So that is Cogni, and we are building virtual learning assistant technology. Thank you.
Next up, we have Julie Mullen, followed by Jonathan Peter.
I don't know if I'm tall. Oh, good. Hi, I'm going to break the mold, and I'm not going to use slides. So let me start by asking, how many people here have actually taken an online course? Yay, okay. So I actually have two different hats that relate to Open edX. One, I teach at WPI. I teach an online course, a graduate course in numerical mathematics, but finite element methods. But a lot of people here are doing that sort of thing. So that's really not the side I want to talk about. The side I want to talk about is I also am a subcontractor at MIT Lincoln Laboratory, where we have a large number of engineers who we teach a large number of courses that are really a series of seminars or presentations. So that's one aspect. So we've started looking into doing small private online courses and using the Open edX platform. And the focus that I want to talk about is our pilot. So we have a very, we teach high performance scientific computing, which is different from other types of computing. But the issue is that we're teaching parallel computing, which is very hard. We've been trying to teach it in the United States and worldwide for decades, and it's still a very small handful of people who are experts at this. But we have a very successful way of teaching it at Lincoln, and we can get people up and working and running parallel code and being productive in 2 days. So what we do is we walk into someone's office, and just like a doctor, we do an assessment. We ask them what they want to do, and then we quickly dial back and discern what we need to do so that we can target our tutorial to them and get them going. That's what we need to now bring into our online course. And if you're at all familiar with the high-performance computing landscape, you'll know that it goes from everything from job arrays, which you're just sending tons of jobs out there, to MapReduce, to bulk synchronous, which is like a MapReduce. You reduce it, now you gotta do something else, and then you gotta reduce again, you gotta do something else, to fully parallel big weather simulations. So if you're gonna go across that landscape, now I wanna bring that to our users and train them without having them learn every single aspect. Because we also know that if you're working on a project this year that's throughput computing, then you'll have forgotten the parallel piece by the time you come to a project that needs that. So the real question is, how do we bring that discernment into an online platform? Because educators know that it's that discernment that separates the really excellent teachers. When someone walks in and they're confused, they can't form the question, you help them form the question. Once they form the question, they can answer it. But that discernment is the piece that makes really good learning. And so the question is, how do we bring that in? I built out my course using, you can think of it as a signal flow graph, but essentially concept mapping, and put the pieces in so that I could have people jump. And I was really excited to see that there's this new team that's going to be working on hinting and tagging, because I think that's one way to do it. But if there are people out there who are interested in trying to make the platform more adaptive so that I can actually give my users 3 questions and based on their answers, send them to the right path, not just the right starting point, because then it's linear after that, but down the right path. And I know that's it's a big thing I'm asking. It's not a this year, it's not a next year, but if there are people out there that want to start that conversation about how we're going to do that, that's really what this 5 minutes was about. It was about the invitation to that conversation. And a secondary invitation is that I have to train other people. Remember back, I mentioned those people who give seminars, and we put the bunch of seminars together and we make a course on, say, radar processing. I have to teach those people how to think about the edX platform and build courses for it. So if there are people out there with expertise and best practices, or who want to help me build out a document, I'm very good, I love documentation, I've come to love it. Documentation on best practices, come find me. Thank you.
Now we have Jonathan Peter, followed by Nikhil Dvaka.
Hi, everybody. David encouraged me to hold a speak as a non-developer. I want to ask, how many of you have never set up an edX instance before? Wow, he was right. There are a few. I'm surprised. All right. So I'm not a developer. I'm Jonathan JP, but not John, Johnny, or Peter. I'm just showing you that I'm human. So I'm from Switzerland. I like to surf. I have a mustache because I'm doing Movember, so usually I don't have one, don't worry. I like to cook, but I'm not as good as him, I guess. And I take pictures, but not with that. So what is this all about? It's about edX experience as a non-developer. So I want to show you why I'm using edX, or why we're using edX. I'm co-founder of Blue Planet Life. We create green jobs for the youth. We're a social business. That means we're purpose first and not for profit. We're an education service provider for young children age 16 to 26, mostly in developing or emerging countries. We have 5 vocational trainings that we're working on right now, of 3 years each, and our target audience are branching partners and education partners. We have a team of 7 people, and most of them are in the education business. So I'm obviously the one left with technical knowledge, with a lot of IT background, but not developer. These are the 5 jobs that we offer. It's environmental specialist, recycling, water treatment, organic farming, and renewable energies. So we chose edX, and that a while ago, because it's a really great platform, and thanks to all of you who contribute to the code. It's really awesome. But vocational training has a theoretical and a practical side. And the theoretical side, we want to teach using edX because we don't want to print books and all that kind of stuff. We want to be able to adjust the material as we go along. So that's what we do. Now, I learned that edX is not like WordPress. You don't just install it and zimzalabim, it's out of the box there. It's also not as easy to install as Ubuntu, where you can just click. And it doesn't have an app store in it. So if you want any of that fancy stuff that people have been talking about, you need to know how to put it in there, and it's not that obvious sometimes. Some of the challenges that I've had were, for example, finding information. There's a lot of information, and you can read yourself to death, which I do every day, following all the Google groups and everything. But there's lack of proper documentation which you can actually use in a case of, not being a developer. And it's a very complicated piece of software with a lot of stuff in it. So I have to hurry up a bit. And a very complex architecture. Thanks to Fennel for this yesterday in track 1. It was a really nice presentation. And to get started, for everybody out there who hasn't started yet, I suggest to use the Sandbox playbook, run it on an Ubuntu. I recommend 4 cores, 8 gig, 80 gig of storage, and then follow the manage production stack. I'm sure most of you know about that. And then once you have that, during installation, I use Ansible to install it. I don't use Vagrant. You run into all these issues, and then you're trying to find solutions in the Google groups, and thanks for all your help there. It's really great. But sometimes people like me don't understand what the solution is because it's written in gibberish. So I try to implement it somehow. And just before I came to the conference, I managed to get Aspen running for the first time, which was awesome. And then you try to do fancy stuff like, overriding your default web. Never works anyway. So, yeah. Then theming is really difficult. I tried with IONISX. I was so proud of myself when I got my logo in there. Updating is not an option if you don't know how. It always breaks your machine, no matter what. And seek help, because the groups are really here to help, and they're great. It's been a very steep learning curve, and it's still very steep. I've learned Ansible and try to learn Django to kind of understand a little bit better what I'm actually doing. And one thing I've really learned is check the log files. That's it.
Next we have Nikhil Dubaka, followed by Dave Ormsby.
Hello, everyone. That's me. You can call me Nick. I work at edX, and I'm going to talk about the XBlock module that I have been working on. Short disclaimer, I have very, very little knowledge of Python, so you can imagine how bad the Git repository would look for this XBlock. I am a Drupal guy. That's what I do at edX. So for people wondering what Drupal is, it's a PHP-based content management system, and we use at edX for the marketing side, the edX.org. So I observed this problem, especially in Drupal community, and I believe it's the same problem across the board for all the programming languages. Like, there are people who want to learn a language, who want to excel in it, and there are businesses who want such kind of skilled programmers. They just don't want freshers, but they want some experienced programmers. And the project, the language itself, like Drupal or Python or edX, the project needs more features, or it has a GitHub issue queue, and it needs to be resolved as quickly as possible. So these are the three problems that I have noticed, and I'll try to address this in the thing. So if you have heard about reCAPTCHA, I'm sure most of you have heard about it. It's like CAPTCHA to prevent spammers from spamming your website. And the reCAPTCHA is like, it shows two words, one a known word and the other unknown word. And it asks the users to type the unknown word. And that way it can, while it's stopping the spam, it's also digitizing the text, like Google uses for maps or something, where the optical character recognition can't recognize the text. It will ask the user to fill in. And I guess it would show for 10 users, and based on the output from the 10 users, it would figure out which one is right or what's the exact text for that particular image. So the same developers of reCAPTCHA also did this. Duolingo, it's a language learning platform, and people who don't know, it's not just a language learning platform, but it's also a text translation platform. Like, people who are learning languages, while they're learning languages, they also try to translate the whole web, like Wikipedia or something. Like it shows the language, like if you're learning Spanish, right? I mean, it shows each words, and it allows the user to learn it. But then it again shows a string of text that Duolingo doesn't know what the Spanish version of it is. But it shows the same text to 10 users, and based on the feedback from the user, the translated thing, it would use machine learning and that kind of stuff to figure out what the right translation for that is. So taking the same concept for these languages into programming languages, like every programming language has a patch, like HTML, JavaScript, CSS, whatever language you take, there is a patch. Like, there is an old code and there is a new code. And there are issues where someone asks to do something and people modify the code so that the new code is generated and patch is generated. So the patch shows the difference between what was done. And that way I figured out, like, if you show this patch to 10 users, like let's say it's a closed patch for a project. It's a closed patch for a project. And so when you show a closed patch to the learners, the platform knows that it's a closed patch and that's the right patch. So depending on the user's feedback to the closed patch, the patch will figure out what's the capacity or what the learning skills of the user is. And it could show an open patch, which the platform doesn't know anything about the patch, if it's right or wrong. And it would figure out, by showing the same patch to 10 people, it can figure out if the user says the patch looks good, or that was the right patch for the expected behavior kind of thing. So I teach Drupal in an OpenEdX platform. It's drupalxcourses.com, and I use similar technology. Like, I show the old code and the new code, and I highlight the differences. And I use Joyride Tour plugin to ask the user, what do you think, why this was done? Like, why was that type removed from there? And the user can pick, and it can show the right or wrong or this stuff. So the people who already know what it is can annotate it. I use annotatorjs.org, and they annotated that this is the reason this was done. And the people who don't know anything about it, they can use this Joyride plugin to figure out if that was right or wrong. And there you go. So to wrap it up, GitHub has a lot of API, and I have written this reCAPTCHA module.
We're out of time.
Yeah, sure.
I'm sorry.
Thank you.
All right, thank you very much. Good deal. Next up, we have Dave Ormsby, followed by followed by, check my notes here. Chris, yes, that's right.
Hi, folks. My name is Dave Ormsby. I'm one of the lead architects here at edX, and I'd like to talk to you about a personal obsession of mine, which is grades and grade calculation. So when we calculate grades in the edX platform, either to display the student's progress page or during the certificate generation phase, there are essentially three things we want to know. What did they earn? What was it possible for them to earn? And finally, what is our policy? How do we aggregate and weigh their scores in order to actually give them a final grade for the course? So now we're going to dive into a little bit of details about how this actually works. So by far the most common store for raw score information is the student module. And this is a implicit, every time your XBlock generates a grading event, we store it in student module. The other, Kappa uses this. It's by far the majority of our things use this. Another interface is the Submissions API. The Submissions API was originally created for the Aura 2 project, which does peer assessment, AI assessment, self-assessment. And the reason why it was created, there are a couple of requirements that student module didn't quite fit the bill for. First is that we wanted very explicit auditing of this student created this submission at this time. This score applies to this exact submission that was done. The other requirement that we had was that students are scoring each other in essence. So student module doesn't really allow you to access the state of another student's score, just your own score. So whenever you have cross student scoring, you need to have some other mechanism. The other way we get raw scores is actually in your XBlock. By the way, it says XModule and XModule descriptor. If you're not familiar with what those are, just mentally substitute XBlock for all of them. So we actually do ask the XBlock for scores. If always recalculate grades equals true on your XBlock, please, please, please do not use this. It is horrible for performance. We are trying to kill it. And my computer fell asleep. And DB can open, okay. So in terms of determining what was possible, we have basically we want to see what the content tree is. And for people who are wondering why their certificates take so long to generate, this is actually by far the worst offender in terms of performance. It is really expensive to actually see in the platform right now to see what is the full set of things that a student can be graded on. So we have both sort of static containers, which are sequences and verticals and so forth. Then we have A/B tests, which we actually have specific student state for. So we have to determine what the tree is for the course in general, but then we also have to determine what part of the tree that this specific student is actually seeing. And finally, we have things that are sort of policy related. So this has score, whether it's XBlock is even a scored type, like a video would not be. The weights, what we scale up this particular problem to be versus other problems in an assignment. And the overall grading policy, which has rules like, drop 2 homeworks. Homeworks are 40% of the grade, final is 30% of the grade, and so forth. So why I bring this up is that grading is something that is used a lot in our platform. It's a major performance concern, and it needs to get a lot better in a couple of dimensions. First, it needs much stronger auditing. So in sort of explicit tracking, Submissions API is a step towards that. And the second, we need to make some substantial performance improvements. So in any case, for more information, please go to that URL or contact me. Also, as I will say this sadly one more time, if you are considering doing always recalculate grades equals true, please come talk to me. But yes, thank you.
Now we have Chris Dodd, followed by Molly DeBlanc.
Sorry, have to swap out machines. So this is a follow-on talk from what Andy Parsons from McKinsey presented yesterday. I just wanted to show the edX side, particularly the technology regarding what has been launched as the McKinsey Academy. I'm going to go quickly through the slides just to get to the meat of it. I just really want to acknowledge a lot of great partnership between McKinsey and their McKinsey Academy division. We are edX Solutions. We are a development team inside of edX. I really want to give a big shout out to both Xavier and his group at OpenCraft, as well as the wonderful team at Extension Engine. They're both here at the conference. They're Open edX development shops. Please reach out to them if you need some assistance in any custom development. So moving on into the partnership, I'm just going to blow through this. So McKinsey and edX formed a partnership early this year. They're trying to provide professional development for Fortune 500 companies. And what's a little bit different about the McKinsey Academy is that it's not a MOOC and it's not a SPOC. It's really small cohorts of students in the low hundreds ranges. And it's a white glove, high touch experience because it's really for professional development. We went through some betas in the summer of this year and we launched in September. So the big challenge is here and why I'm up here and I wanted to talk to you because we had to push OpenX as far as possible. The edX Solutions team, we are kind of chartered with pushing these kind of boundaries and I just wanted to present it. So our challenge was really how to use OpenEdX as a platform as opposed to a standalone application. So, we really struggled with the notion of having the presentation tier being really tightly bound to all the business logic and the data tiers. And one other challenge was that McKinsey, even though security is important for everyone, they have chief security officers that have to approve a lot of this stuff. So I'm going to hop over to the website right now, and then I'll go more into the technology. Believe it or not, this is OpenEdX. This is a demo course on production, so it doesn't have a lot of good user data. So I'm just going to go through some of the features that we developed and how we developed it. Like again, this is OpenEdX, believe it or not. It's not a theme, it's not a microsite. It is basically a custom front-end application that was developed as a separate set of processes that connect over APIs to OpenEdX. That was one of the innovations that we had to take on. I think everyone's talked at the conference about how APIs are really critical to edX and OpenEdX success. We kind of pioneered the way for a couple of things. So as you can sort of see here, you have basically courseware introspection, what we call chapters, they call lessons. So just to give you a couple of the highlights. So basically, these are querying APIs on the back end from the customized front end. It seems like bandwidth is really slow right here, but what's actually rendering right here is actually an X block, and that's something I want to talk about a little bit more in detail. One other highlight is really a lot of the data aggregations that we wanted to do. The McKinsey Academy has the notion of kind of light gamification where you compete against your cohorts. What McKinsey call cohorts, you would call kind of your course enrollment. So I got 2 minutes left, so I want to get into the technical side of things. Sorry. Okay, go away. There we go. So on the technology side, so this is basically what it is. So at the top, you have a custom Django application, which is codenamed AppRose. That is which represents McKinsey's custom UX and UI. Down at the bottom is basically your OpenEdX stack. You have Studio. Everything that you saw at McKinsey Academy is actually produced by Studio. We made no modifications to it whatsoever. The proprietary app calls these new APIs that we wrote out, which are hosted inside of the LMS process. What else is important to note is we use the LMS for hosting the X blocks. That was an innovation that Xavier came up with. So we're using the standard MySQL and MongoDB backends, and the McKinsey Academy has its own private DB for some custom stuff. So basically, the big thing was a server-to-server API that's in our fork of edX platform. It's in edX Solutions repo. So basically, you log in, log out, query your courseware. Following on Dave's talk, we came up with a grade book to optimize grade calculation. And there's a lot of things regarding rollups of metrics regarding work groups and other of your cohorts. So, okay, so if you like what you see, go to edX Solutions repo or come talk to us.
And our last lightning talk of the day is by Molly DeBlanc.
Are you asking tech support? Hi, I'm Molly DeBlanc. I need to hit view. Where? Oh, there it goes. Now, how do I make it big? Oh. I am using a Mac for the first time ever. So thank you all for bearing with me. I'm the new person on the Open edX team, and I'm here, and I'm kind of the radical leftist hippie free software person. So I'm going to use the term free software a lot. If you're not familiar with it, hopefully you will be. And I'm happy to meet you and talk to you about why I'm at Open edX. And I'm here because Open edX uses the AGPL. It's a free software license. Free software licenses were designed and maintained by the Free Software Foundation, of which Gerald Sussman is a member of the board, yay. And the AGPL is built on what are called the 4 freedoms. These are different from FDR's 4 freedoms. And they're based around the right to run programs as you wish. You can do whatever you want with the software you have. You can learn how they work. You can look at the code and you can change it. You can share copies, right? So, okay, so anyone can grab Open edX from GitHub and they can install their own instance. And also you can all share what you've done with it. This isn't just you kind of hack on it by yourself, but you can give everyone else what you've made happen. Here's some things I like about the AGPL and its application. You can use Open edX to make money. Who doesn't like money? You can change Open edX, right? So you can make it be what you need it to be. We've created an instance on edX.org for millions of students and hopefully billions, right? You might be running it for 300 students at your middle school. You don't need the same things we do. You can also share what you've done with it. It's great. I also like that you have to share your code. Right? So the things you do, because they have to go out to everyone else can benefit from it. You also have to relicense. That means you have to use the AGPL. You have to use our license. You can't change it. Some people call these viral licenses. I don't like the word viral. Software isn't a disease. Free software isn't a disease, and sharing's good. Why is sharing good? Well, if you're sharing your code, you're making Open edX better. We have more features, we have fewer bugs, and we all have a better chance of doing what we want. The people out here who are hacking on it, who are making the big changes, you're helping the sysadmins at the middle school with 300 students who might not have the time to make that happen or the ability to make that happen. There are more Open edX instances, the more we can share our code. Education is good. We all think education is good. That's why we're here, right? My brief little radical rant about why sharing code is good is that we can see what's happening, we can change what's happening, and nothing we don't want to happen goes on. Here's some not so practical reasons. I am a product of a public school education system, so in kindergarten I learned that sharing is good. This is just something I think. I think education is a right. We all should be educated. We all deserve to be educated. We all deserve to be able to know what we want to know and learn what we want to learn. And then my little radical rant about why sharing code is good is it means, I had an answer here. All right, we own computers. We own the code on our computers. We own the software on our computers. If we can't look at it and if we can't change it, we don't really own it.
And I think that's a problem. In summary, FLOSS, free Libre open source software, is good. We can understand what we're doing, we can change things, and we can share those things. Education is good. So in summary, please help us take over the world with free software by working on open edX, by sharing open edX, and by helping the rest of the community and participating in it. That's all I got.
Okay, that's the end. Whoa. I'm shorter than she is. That's the end of our lightning talks. There are bag lunches. We sort of did that just in case there were some folks that needed to leave and wanted to take it with them. But we hope you won't leave because there's a full agenda for the rest of the afternoon, which includes all of the breakout sessions, again, just like yesterday afternoon. And they're handily in that flyer that we handed out. So maybe I should just review them quickly for the group. Let me just get that. Okay. So in Byerly, do we still have that map that we had that was up here yesterday? It's fine. We'll put it up there in a bit. In Byerly, track 1, that's hosting and adopting. UPV, EdCast, and MIT are all going to give talks there. Track 2 is in Shear. That's the building immediately close to us here. And that's developing and innovation. So we have Indiana University, Achievery, GW, IBL, Google, and Stanford. And you're asking me, how the heck are all of those people going to fit into that time slot? It works. It's going to happen. And track number 3 is architecture. And that's going to be all edX folks addressing various different topics. And that's right here in this room. So we will take a quick break to have lunch. Actually, a good size break. How long do we have? An hour, I suppose, to mingle and eat. And then 1 o'clock, we'll start the breakout sessions. After the breakout sessions are over, we'll welcome you back here and have some closing remarks. And then we'll have unconference time starting at 3:30. And that can be in this area, upstairs or downstairs. 1 second, Serena says she has something to say.
There's been a lot of questions about will slides be publicized, and we didn't get slides from speakers in advance, but we're going to be emailing out to everybody after the conference. We're going to be asking if you'd be willing to publish your slides. So just check the conference website. We'll hope to get those up along with all the archive video within the next 2 weeks. So thank you for that.
Yes.
No, I was just going to suggest leaving it up there, but you're leaving it up there.
So my voice is muted.
You didn't show it to me. You said